electrical signal first enters the nerve cell through the dendrites, and from there it goes through the cell body and down the axon to the synaptic terminal. And at the synaptic terminal, it will go to the calcium ion channel and cause it to open, and this causes an influx of calcium ions into the cell. And this will cause the vesicles containing neurotransmitters to fuse with the synaptic terminal, and this will release it as seen here. And then the neurotransmitters will cross the synapse and bind onto a postsynaptic receptor. And this will cause an excitatory or inhibitory response.
Alright, so here's a close-up view of the node of Ranvier. Okay. Anyways, so when the electrical signal goes from the dendrite to the axon, a ligand attaches to the sodium channel, which opens it. And because it's more positive charge on the outside than the inside, sodium channels rush into the inside of the cell, which changes the membrane potential. And the change in membrane potential causes other sodium channels, such as this one, to open, which causes further sodium ions to flow in. And when the membrane potential is positive enough, it reaches its action potential. And once it reaches its action potential, that causes a closing of sodium channels and the opening of potassium channels. And the opening of potassium channel causes hyperpolarization, which is caused by the potassium ions getting out. And once the membrane potential is negative enough due to the potassium ions flowing out, the sodium potassium pump with ATP brings 3 sodium ions out for every 2 potassium ions. So that keeps the resting potential at negative 70 millivolts because more positive charge is being flown out than brought in.
Alright, so here we have a graph of memory potential versus time, and it starts in the resting state and then goes up due to depolarization. And here, this dashed line is the threshold, and once it passes that, it goes to the action potential, which is right here. And then once that happens, the opening of the potassium channels causes hyperpolarization, which is here to here, and then that will return it to resting state. And then over here, we have a graph where it doesn't reach the threshold, so the action potential isn't reached, which causes it to go back into resting state.
Tetrodotoxin is a potent neurotoxin. It is a sodium channel blocker. It inhibits the firing of action potentials in neurons by binding to the voltage-gated sodium channels in nerve cell membranes and blocking the passage of sodium ions responsible for the rising phase of an action potential into the neuron. So basically what it does is it prevents the sodium gates from opening enough for the threshold to be reached for the electrical signal to be sent.